if two wheels are locked on an axle so that they are not free to turn separately, one or the other has to slide. So engineers had to find a way to connect both rear wheels to the engine without sliding and slipping on turns. The device which makes this possible is a part of the rear axle. It is called the differential because it can drive the rear wheels at different speeds. The differential looks complicated, but once we understand its principle, it is amazingly simple. These two wheels are mounted on separate axles and supported by a frame so that they can revolve freely at different speeds. Let's fasten a spoke on the inner end of each axle so that by turning the spokes, we can turn each wheel separately. With a bar or crosspiece, we can turn both wheels in the same direction at the same rate of speed. Let's get something to hold this bar in place so that it will press against the spokes. Notice that this support is not locked to the axle. It turns freely. Now we can spin the wheels by rotating the support. This is fine as long as both wheels are able to turn at the same speed. But let's see what happens when we go around the corner. With this arrangement, we cannot drive one wheel faster than the other. And if we stop one wheel, the other wheel won't budge. Let's put this bar on a pivot so that it can swing in either direction. Now, the bar can still turn both wheels at the same speed. And because it pivots, it lets one wheel turn even when the other is stopped. But if turned too far, the bar will swing around until it won't drive the spokes that turn either wheel. We need another crossbar and more spokes to carry on the job. When we stop one wheel, the crossbars will continue to push the spokes of the free wheel around. As long as both wheels are free to turn, the bars do not swing on their pivot and the wheels move at the same speed. Now we have the working principles of a differential. To adapt the model for use in an automobile, we will have to make a few changes. In order to reduce the jerky action caused by wide spaces between the spokes, we will put in more spokes. Further filling in the spaces between the spokes gives steadier, more continuous action, and changing the shape gives firm, constant contact. Now we can make the gears thicker and stronger, and we have differential gears. The edges are cut so that they will fit together more smoothly and silently, and another gear is added to share the work of driving the axles. The principle is the same. In order to turn the support and drive the wheels, we can fasten a large gear here, connected by a smaller gear to a source of power. Notice that the power is connected to the differential at the center line. We can make our model more compact by moving the gears closer together. When we put our differential in an automobile, we have to leave room for the drive shaft, which carries the power from the engine. We may build the floor of the car above the drive shaft. But if we do, we won't have much room inside unless we make the top of the car high too. Of course, we could lower the floor and ceiling, but the drive shaft would be higher than the floor. This would have disadvantages. A shaft in the middle of the floor of an automobile would be inconvenient for passengers and would be awkward for carrying luggage. Today, engineers have found a way to make the car roomier and closer to the road without a clumsy shaft above the floor. The drive shaft from the engine to the differential is lowered out of the way, and the drive shaft is connected to the rear axle at the bottom. The new low center drive makes the rear axle quieter, stronger, and more durable because it gives better, smoother contact between the gears. The automobile of today with the low center drive is stronger and more rugged. Every part of the rear axle has been built to withstand strains far greater than it will ever meet on the straightaway or around the corner.